incredible breadth of technical expertise, including security solutions and extensive work on DevOps. Nathan, welcome to Open Source Friday. Thank you for being here.
Thank you so much for having me.
I am so excited that you're joining because when I saw your project, well, first of all, I think I have questions, and we're going to get to the questions as well, because I feel like now there is a ton of solutions out there that are integrating ChatGPT and ChatGPT-like capabilities. When we're talking about very specific things for things that are extremely important and that are technically just such a heavy load, right? When it talks to about things about cloud monitoring, observability, there isn't a ton out there that's actually like real solutions that don't require a human just being there monitoring everything all the time. And it's such an important part of infrastructure and scaling projects. And if you have a company, this matters to you. So I want to, first of all, welcome you to Open Source Friday. And secondly, ask you, what was the inspiration? Like, why did you feel like you needed to build Holmes GPT?
Okay, thank you so much for having me. And we're going to get into all of that. But I just want to start maybe with one thing I do want to emphasize is that we're not replacing the human. We're not at the point where we can do so. That I think we're
Thank
not.
you for that. Yeah.
Not aiming to do so.
We're augmenting. Are we augmenting?
Yes.
Beautiful.
Like I think there are live cases today, for example, with GitHub Copilot and with other tooling. And of course, with ChatGPT even in daily life, which I use sometimes to get ideas for what I'm going to cook next and recipes I might have thought of. There are live cases where that can really augment you, make you a little bit faster when used in appropriate ways. There are things it's great at, there are things it's awful at, but when used appropriately, that could be a really useful tool. So we're trying to make engineers out there better and give a lot of those engineers and teams ways that they can do things faster and better. We're not replacing the engineers. And then what we'll try and do this hour is like kind of walk through what we're doing, but also walk through the ecosystem. There's a lot of other tooling out there. Of course, Kate's GPT is probably the most well-known one. That's KAS GPT. That's not what I developed, but I'll talk about that and like the ecosystem and how the different tools fit in. I'd like to speak a little bit also kind of about what we see with enterprise adoption. There's a trend that we're seeing a lot of what I would call BYO LLM, bring your own LLM, where
I love that.
Can use these different AI tools with stuff that is enterprise friendly, where they bring like kind of their own stuff, so they're not sending data to you and so on. So we're going to talk about the whole ecosystem, but we're probably going to start with like the why and why any of this matters. Why would you even want or need a tool for an AI like tool for observability and chat? And on call. Why ChatGPT can't do that, and then we'll get into all the different solutions. Does that make sense?
That sounds good, and thank you for the clarification. Definitely want to make sure that folks that are watching, this is not coming for your jobs. This is coming to make you work better.
So let me start with a scenario that I've experienced, and I think many people experience, which is that you're working in a company and you have production, and probably you joined the company maybe a year ago, 2 years ago, and there's live stuff that's already set up, and something goes wrong, right? And it's like 3 a.m. and you get paged, or if you have a less mature on-call practice, maybe it's just like 2 in the afternoon and someone says, oh, go look at this. We're getting a lot of alerts around X. Or the worst thing that could happen, a place where none of us want to be, you get a call from your company gets a call from a customer and they say something's not working. You go, oh, we didn't even know it's not working. And then not on go and investigate. So we have a problem, ideally a problem that we noticed ourselves and not our customer, but we have a problem. And I've been in scenarios where we find out from our customer. And I can almost guarantee you that the answer to whatever problem is occurring, you already, like your company already has the right data. And I can almost guarantee you that like there will be a Grafana dashboard somewhere that is set up, or that someone in your company set up, that like if you only looked at that Grafana dashboard in the first 2 minutes of getting that call, you would solve the problem. Or if you only ran a certain command to gather certain data or to see certain information, if you only looked at the right screen in your observability tool or saw the exact log that's relevant, then you would solve that problem. But
so the data's there, but you need a human to look at it.
You need a human to look at it, and you'll need a human to look at it. But I've been in teams and in companies, and I see all the time, like companies that we work with, it takes a very long time often to look in the right place. And there's a big amount of variance between the most skilled engineers on the team and between the more junior engineers and the newer engineers. And there's some great polls also, like, or we've done a little bit of polling around this also, even on LinkedIn. But there's a big challenge today for junior engineers. There are actually less junior engineers being hired across the industry. And those junior engineers have a higher expectation set for them because they want to be better because now there's all this AI tooling. So the junior engineers on your team, and we want that junior engineer to be effective as soon as possible. And every team lead wants the junior engineers on his team to be able to take problems like that and go off and investigate them and find the solution fast. But some of that you kind of just learn over the years how to troubleshoot and where to look. So the question is, can we make junior engineers better at that by maybe helping them find the right thing right away? Like, think of autocomplete when you do a Google search, right? Like, that's not replacing you from searching, but it's helping you get to where you want to be faster. And the question is, even for the skilled people on your team, can we service up the right data faster? And you mentioned PagerDuty. So PagerDuty is like an example, actually. We'll speak about that as we speak about the open source and integrations. We have an integration in PagerDuty. So like conceptually, like this is one thing HolmesGPT supports, take a PagerDuty incident, run an automated investigation, surface up the relevant data. Now, whoever is responding to that, by the time they open the PagerDuty incident, all the data that they need to go and to investigate is right there in front of them. And therefore, you can like get your production up and running faster, solve that degradation of production faster, which means, of course, your customers are happier. Your customers are happier. It means like the engineering department is happier because your engineers are now back developing features, not doing on-call work. There are all sorts of benefits to that.
And if you're a junior or new to the team, you get to be a hero too, right? Because you get to see you have been augmented by the tools that you have at your disposal now. Thank you for that context. That is extremely helpful. So you were obviously looking at a lot of problems from personal experiences, from having been there and having, whether it be tickets from your customers or trying to improve like resolution times for issues that are happening, whether you identify them quickly or they became a problem and then they were identified. And so that brings us to what we're here to talk about. So if you don't mind, I'd love for you to lead us through that with the context, lead us a little bit about the solution itself. And I think, do you want to share the screen? We can take a look at some of the slides.
I would. So I want to maybe talk for another 60 seconds and then I'll share my screen. And I'm going to get the solution after I explain all the things that don't work, because I think it's really important to, I'm a skeptic by background, right? And like, I'm naturally a skeptic. And when you say, okay, can we take AI and use it to solve incidents? Well, like that's a bit of a big thing. But I want to show you, I'm going to walk through this and kind of build it up from scratch in maybe 3 minutes, is why parts of that are actually really easy, but it does need dedicated tooling. So let me start. So let's just imagine a scenario. I'm running a Kubernetes cluster, and I will show live demos around Kubernetes today, but nothing here is Kubernetes specific. So imagine I'm running a Kubernetes cluster and I have an application on there. Imagine I'm an e-commerce shop and my customers complain, like, your e-commerce shop is loading really slow. I'm trying to check out and like, I can't check out, the checkout page is stuck. My company cares about that because that's lost revenue, right? If people are not checking out or they can't check out, I mean, that's lost revenue. If they can't go and check out and buy whatever they're buying on my e-commerce shop. So what I would want to do, right, and this will obviously not work, but let me explain, like, I'm going to do something really dumb, okay? So excuse me for doing something really dumb. But like, this won't work, right? I can't go over to ChatGPT and say like, why isn't my...
Hang on a second. Let me share your screen so we can see what you're typing. Okay, here we go. So
I can't go like to ChatGPT and ask, why isn't my e-commerce shop working? Or like, why isn't the, I don't know, customer checkout pod not working? If I translate that to more technical terms, like, of course, ChatGPT doesn't know, like, it doesn't have my data. So actually what it can know, what it's doing that's interesting, is it's giving me kind of steps for how you would go off and you would check that out, right? So it's saying, well, go check pod status, right? Go check pod events, go inspect logs, inspect the pod YAML. So it can actually give me instructions for what I should do, but it's not connected to my live data, so it can't actually go off and do that, right? So the core concept of HolmesGPT, and I'll show this first in the SaaS platform, and then I'll loop over, I'm now showing the terminal with the open source, the core concept of Homes GPT is that we can actually ask an AI engine, ask a large language model like OpenAI or others, like, given this problem, how would you troubleshoot that? And then it gives us back instructions. Well, go and troubleshoot it this way and that way and that way and run these commands. And we can actually go off and run those commands. And then we can go and feedback, like put in back the feedback saying, like, I ran those commands and here's the output, ... What should I run next? And essentially what we're using a large language model to kind of guide that troubleshooting process and the data gathering process. And we can have it say, oh, like, well, maybe look at this graph on the dashboard. We can have it say, oh, maybe look at these logs. And then in the logs, it mentions like a problem with your database. So then maybe it would say, go off and look at the database logs, right? Or look at information on database performance. So essentially the core concept, and we will show this, and I will get out of this kind of trivial example that doesn't work with ChatGPT very soon, is we can use AI to determine, kind of given a problem, what is the right data to look, gather that data, feed it back in, kind of do that in a loop. Does that make sense so far?
Yeah, we're tracking.
Okay, so let me just show that in action, and maybe I'll jump over here. And I'm just going to ask a question. So I'm going to ask, for example, what is wrong with, I don't know, let's tag something, analytics exporter, right?
For clarification, we are now looking at Homes GPT.
This is Homes GPT.
There we go.
This is the SaaS platform for Homes GPT, and I will show you afterwards. I will show you the terminal version. I will speak a lot about like how it actually works and how you can extend it and so on.
Okay, perfect.
I think it's useful here. Okay, so I get an answer, but before I even look at the answer, I want to just zoom in on this part over here where it says gather data with 6 tools. So under the hood, it kind of asks ChatGPT or OpenAI or whatever large language model you set up. It asked it, what command should I run to like answer this question?
Okay.
Then it ran some commands. It looked at the data, it looked at the logs. The logs were empty in that case, right? But it went off, it gathered all this data. And then it gave me an answer, right? It said, oh, this is crashing. And that's because it's umkilled, it's running out of memory. And here's how you could go off and fix that. So unlike doing this over here in ChatGPT, where it tells me, oh, go run these commands, essentially we're getting the commands to run, we're running them, and then we're feeding that data back in and then using that in analysis.
Okay. Did you tell it in the command what data to collect, or was that part of the tool itself? I missed that.
That's
how does it know which observability data is going to look at?
Okay, so excellent question. Let me jump over maybe to slides for a little bit, and I'm just going to walk through a little bit of this because I want to discuss kind of the trade-offs. When you're building a system like this, do you give it access to all the data? Do you give access to limited data? How do you build a system like this in a way that both works and is secure? So before I speak about that, I want to just take a step back on one thing. We've spoken a little bit about this, but like, why should we even want to do this? Well, finding the right data during an incident is hard, right? Not everyone has the experience. And just in terms of the benefits for businesses, right? Like, how would you justify this to your manager? The reason you should go off and adopt a new tool is, well, first of all, reducing downtime obviously makes an impact on the bottom line. And second of all, this is sometimes an overlooked aspect, but it's today very important for platform engineers, is that companies employ hundreds or thousands of developers, right? If you can save an hour or 2 hours to each of those developers every day, that's a huge, huge impact across the business in terms of productivity and what your teams can get done. So sometimes, like, the two main reasons we see why people take tooling like Homes GPT is, one, to reduce downtime, but two, to improve the developer experience, to make all the developers across the organization more effective. So now, if you're building an AI assistant, right, then there are 3 types of AI assistants that you could build. The first uses what's called RAG, or Retrieval Augmented Generation. Essentially, the technology, like the way that works, is you have a question from the user, and then you use something called a vector database to kind of look up relevant information to that question. So typically, you're indexing like all of your organizational data. You're indexing Confluence articles. You're indexing documentation. You're indexing all these different things. And then when you ask a question, you kind of find the relevant articles and you send the question over to the AI, over to the LLM, along with those relevant articles. And then you get an answer based on that. And You see that very often. Like if you look at the AI assistants that are built into Google Cloud or built into Azure or into AWS, they are typically RAG-based. So typically the way they work is you ask a question, it finds relevant documentation, and then gives you an answer based on documentation. And when it's done well, it also links back to the documentation. So kind of that's the first type of AI agent that people often go and build. That can't work for this type of use case. So for this type of use case where you're dealing with observability data, for various reasons, you can't index that data in a vector database and get good results. It's huge amounts of data. It's dynamic. It changes. There are all sorts of technical reasons why it doesn't work well, but you can't take this type of solution and expect to get good results for observability. So like when a lot of people have started by doing stuff with LangChain around RAG-based solutions and pulling in data and these knowledge articles and stuff, that is great in general for building AI assistants. So building AI assistants for observability that doesn't work very well. The second type of thing that people do, and this is what tools like K8s does, is what they call environment aware, what we call environment aware. And environment aware essentially means you go off to ChatGPT and you would go off and you would like ask a question like, what is wrong with analytics exporter? Here are the logs for it. And then in advance, you have some logic that says, given like this type of question, go off and fetch certain data in advance and just shove all that data in over here into your question. And then you get back the answer and you're done. That's a decent approach. It works really well for the simple things. Like if I have a pod and I want to know what's wrong with that pod, then like I can go off and I can do that. Where it doesn't work is on like real world observability questions, because those almost always are multi-stage. Like you have a problem with analytics exporter, but then you look at it and actually the problem is with the node it's running on, but then you look at the node and actually the problem is with your Google Cloud setup. So typically you can't do, this is like one shot, right? You're asking a question, you're shoving in some context, and then you're getting back an answer. But a human doesn't work like this. The way a human investigates is a human like asks a question, they look at the data, then they ask a new question based on what they saw in the previous one.
Mm-hmm.
So this approach, which is the approach that tools like K8s take, is really good for the simple stuff where you're looking at something you want to pinpoint answer based on that specific thing. But when you have cascading errors or dependencies between different things or things that would require looking at multiple data sources and joining between them, then this type of approach tends to break down. And then the third approach is what people now often call the agentic approach, where you have an AI agent. And essentially, that has this loop. So it's like a for loop in programming, right? Like you run a query, you get data, then you run another one, you get data. And along each stage, you're repeatedly asking the large language model or the AI, what type of data should I gather given what I've shown you so far? And then you gather data in the loop. And that's really how humans investigate. And that's the approach that we chose for Holmes GPT, because that's the approach that starts to give really good answers. Now, I want to loop back, though, to your question. So we have an AI agent, right? So kind of conceptually, what we're doing is we're asking AI a question. We're saying, okay, but don't answer that question right away. First, tell me what command should I run to answer? Oh, you run those commands. Here's the result. Okay, should I run more commands, right? You go and you do that in the loop. But what are actually those commands that has access to? So there's something really scary like about just saying, oh, take a bash shell and run any command you want. That wouldn't work for safety reasons. So there are two approaches you could take, right? One, you could give the agent access just to anything to run commands, but that would have safety concerns. And the other way is you give the agent access to specific integrations that you approve and can do read-only access to the data that it's set out to access. So that's, again, the approach that we've taken. So then to go back to your question, what sort of data can I ask over here and where can I get those answers from? So it would have to be something where we added an integration or where you gave it explicit access to that data. Those integrations are really, really lightweight and easy to add. So you can get anything in there, but it's only accessing read-only data that is pre-approved to access.
Great. Okay. And what types of data can you ingest? Like what can it be integrated into it? And so you mentioned a couple of things, but I'd love to.
So out of the box, we have support for Kubernetes, some AWS stuff, I think some stuff around Docker. Very soon we're rolling out support for pulling in data from Loki and probably traces from Tempo, as well as OpenSearch and Elasticsearch. We have an integration with Prometheus out of the box. We have an integration with Grafana. I don't think that's merged yet, but where you can ask questions and it will like tell you what the most relevant dashboard is to look at. And I'll show you in a moment what these integrations actually are, and then you'll understand why it's so easy and anyone can go off and add an integration for anything you need. But one of the really interesting things that we see is that I'm going to stop sharing for a moment. One of the really interesting things that we see is that people will go off and they add integrations for their own company specific sources. So like if you think about how your company goes and investigates problems, maybe you have a Postgres database and like you go and run certain commands on that Postgres database, right? So then something giving access to something like that would allow it to give the same quality results like that you would expect from your team. So the main thing to get good results becomes, am I giving it access to the right type of data sources so it really can investigate and surface up, like for a person, the data that a person would go off and look at themselves.
Interesting. Very interesting. So you give it access, and I have questions. I'm sorry. And folks, please, by all means, ask your questions in the chat. You're authorizing the types of data it's going to be using. But then are you in Flux as well? Like, how do you, I guess, can a human then decide if he needs to look elsewhere?
Well, you just ask a follow-up question, right?
Okay.
ChatGPT, that's the real power of chat. So we present this data in a few different ways. For example, I showed you in a chat interface. So you ask a question, and then it like looked at the wrong thing. You can say, no, look here instead, right? Again, we're not replacing the person.
Okay.
We're guiding it. We're servicing up the right data. Someone said to me recently, like, I know when I investigate, like I would go off and I would check the firewall logs. So like, can I just say, can you check the firewall logs for me when there's a network problem? Like, of course you could, right? Like, so you can kind of guide it and inject your own knowledge. Okay. Then the second way we package that up is connecting it to specific alerts. So if you have Prometheus, we can take a Prometheus alert and then attach to the Prometheus alert this pre-canned analysis. So we take the Prometheus alert, we analyze it. If you have runbooks, or if the runbooks are linked from that Prometheus alert, then first the agent reads the runbooks, then it analyzes according to the runbooks, gathers up all the data. If you have OpsGenie or PagerDuty, it can like read stuff from PagerDuty, do the analysis, and then write back what it found as a PagerDuty comment. But in all of these, what we're trying to build in, we have this ready for Prometheus, but not for the PagerDuty, is that conversational ability. So you can ask a follow-up question, and the analysis is just a starting point to surface up stuff, to show you as fast as possible, like the specific line in the logs that's actually really interesting out of 10,000 log lines. So we want to surface up stuff really fast, but it's a discussion, right? We're showing you the data we found. We're showing you how we found that data and what the sources are. And if you want to go off and check something else, you're leading that investigation process. So of course you can guide that. And then we spoke earlier about like junior engineers, right? So one really cool thing you can do is when you have a problem that occurs often, or family of problems that occurs often, then a senior engineer can just write in, like, when you investigate this problem, I always check Kafka for this type of issue.
That was my next question.
Investigate, right? And then it just does that. And then when the junior engineer sees that, like, you don't need to rely on the junior engineer remembering how to investigate or going off and reading like a Confluence page, or not being shy and asking a senior engineer for help. Like, it just is surfaced up and put in front of them according to the instructions for how the best people on your team may.
So you sort of teach it those like patterns of investigation from, I guess, whoever your more senior people are, and then everyone can use them. That's
we find most companies already have that, just no one reads it. So we find companies already have, like, somewhere in Confluence a run book saying how to investigate, or somewhere in their Slack history maybe a discussion of how to investigate different problems. Right. No one reads it. And this goes back to, I think, how I opened, which is that all the data you need to solve incidents is always there. It just is a question of whether it takes you 5 minutes to find it, or 5 hours, or 5 days. But all the data you need to solve the problems will almost always already be there in your observability tools, in your systems. There are very few incidents where the data isn't there. And I'll give you an example, okay? I once worked on a very annoying IT problem. We had a bunch of ESX clusters, VMware, lots of VMware stuff, and one day they all started dropping network traffic. And we spent over a week trying to investigate that. And we looked at everything. We looked at the virtual machines. We looked at the setup on the ESX. We looked at everything. And in the end, it was a really simple time correlation that found the problem. Someone had laid down new fiber optic cables, and one of them was faulty.
There
was no new data. Like, actually, if someone just looked at like the relevant email or the relevant discussion somewhere, like that was a really easy time-based correlation. Like, someone made that down, and like next moment it was just someone else, and like we weren't aware, but like the data was actually all there. Like no new data like surfaced up, just we connected these two seemingly random dots. So there are very few cases where like you can only solve a very hard problem or an outage because like you really have some new data that wasn't there. Often the data is there, it's just not accessible, or you're not even thinking to look at it.
Very interesting. This is such a unique what you just shared. So I might be getting ahead of myself. Like if there is a way how it would decide if there is conflicting data coming from the different sources, like how does it decide what to prioritize? Which data is the data that's the more relevant? Is that part of the patterns of investigation? Like you give priority, like you could have known that there was a, what do you say?
So often you'll backtrack, but maybe I'll my screen again and let me go over now to the open source CLI and the core engine, like the brain behind all of this. So I'm going to show it now from the terminal, and then it'll also help understand what it's doing. So I'm going to ask a question here, and I'm running this locally. So I'm just wrapping things with Poetry Run Homes because I'm running a dev version. But Poetry Run Homes, and I'm going to start with an ask command. So ask what pods are unhealthy in my cluster. Again, I'm asking about Kubernetes clusters, but this is actually compatible with a wider range of things. What pods are unhealthy in my cluster? Give output as a markdown table, right? And now the first thing we're doing is we're essentially asking the LLM, okay, given this question, what is the type of data we should go off and gather in order to answer this question? So you can see it's running command here, kubectl again. It's listing all pods in the cluster. And it's going to take that, it's going to filter through that, and then kind of look at the ones in there that are unhealthy, and then give me an answer on that, right? So here's the answer. And now what I want to do, though, is I want to show you, I'm going to ask a question here, but the question will have to depend on this data. And I'm doing it as a new conversation session, so it doesn't have the history. Give output as a markdown table, and tell me the image of each one, right? So this is interesting because in order to get this data, first you have to run something like this and get the list of unhealthy pods. And you have to kind of have this table. And only after you have this table can you do a lookup one at a time on each of these and then find their image. So you can't get all this data in one go. So like we spoke earlier about how there's tools that just inject a little bit of like environmental awareness and stuff. Those tools can't go off and do something like this because you're iterating, right? You're asking one question, looking at the results, then asking another question. Okay, and you can see, ask that first question, analyze the results, and then it said go in parallel, like run all these other commands, to gather data. Now it's gathering the data from those other commands, and then it's going to give me an answer after it has gathered all that data. And this again goes back to that cascading failure scenario, right? Where you look up data, then you learn something, then you look up data again, you learn something, you pivot. So here's the answer, and now I have the pods that are unhealthy. That was from the first lookup. And then I have the images, right, for each one, which I had to go off and do a separate lookup on each one.
And this might be a dumb question, but there is no such thing. So how does it determine like what's considered a healthy cluster? Like when you're telling it, look, is this criteria that you've given?
Yeah, so we're relying here on two things. And it's not a dumb question at all. But one is kind of built-in awareness from the data it was trained on. So like in this case, this is a GPT-4o, which was trained on large amounts of the internet. So based on that, and like it has an idea that an unhealthy pod would be a pod that's unkilled, imageable backoff, or crash through backoff, right?
Okay.
Depending. But in general, we try not to rely at all on the built-in data it was trained on, because that's an area where like you're prone to hallucinations. We try and only rely on data that was gathered, that we explicitly fed in the question. So we give like a little bit of guidance also on the different tools, how to identify what's healthy. Like we give it some baseline information on our end for what it should take into account when running these investigations. That's what you'd call prompt engineering, right? So we do a little bit of prompt engineering so that we get it we align it a little bit closer with how an SRE or a really good engineer at OnCall would think.
Okay. Very neat. So explain to me what we're looking at. CLI is the open source portion of what we're looking at earlier. All right.
The CLI is the brain of it. And then you can use that from the command line. You can use that from the command line and analyze Prometheus alerts. I'll show that in a moment. You can use that and fetch data from PagerDuty or AppsGenie and then write back the results. You can use that in all these different ways and integrate with all the different systems. So it was really important for us that all those integrations and even the ability to like take a Prometheus alert and analyze and send the result to Slack, like different stuff like that is all part of the open source. So we wanted to make sure that the open source has its own life and is like completely usable in real world scenarios and hooks up to all the different data sources on its own. And then we have a SaaS platform as well with a heavily free tier here, where that adds on this user interface and some features for sharing with your team and making it easier to hook up to different data sources like via user interface, but it's the same backend, it's the same engine.
Very cool. Okay, let me share the repo for the open source portion of it. But you did say there is a free layer to the SaaS.
There is, yes.
Okay, yes. Awesome.
So anyone can get started with that, or if you prefer just open source, get started with open source. And both on SaaS and on the open source, one thing that's really important to us is what I would call BYO LLM, bring your own LLM, meaning you can use for free like our large language model that we run, which is actually Azure AI under the hood. So we use something that's also privacy friendly. We don't train on your data at all. But if you want, then you can like bring your own API key. We never see that API key, and you can hook it up to whatever large language model your organization is approved to use, whether that's AWS Bedrock or Azure or your own private OpenAI account, and you can hook it up so that like that stuff never goes through us. But regardless, we don't train on your data, and most of the main providers out there, like AWS Bedrock and Azure and OpenAI, if you use their API, they also do not train on your data.
No, okay, and this is even on the free layer of the product, right? So
that's even on the free layer as well.
Awesome. Okay, well, I want you to guide me. What else did you want to share? And then we'll open it up to see if folks have any questions in the audience, if that's okay.
So I want to speak a little bit more on the integrations, the different ways this can be used.
Okay.
And then I want to speak a little bit about the integrations and how you go about adding new integrations. And then I think we'll open it up. So let's get started. So here's an example just of a Prometheus alert. And then let me actually show this to you. If I have a Prometheus alert, then I can go and I can look at, like, I can get an AI analysis of that. So here I'm looking at Prometheus alert. There's high latency on some HTTP service. And first of all, I can go and I can give this instructions on how to go off and investigate, right? So I can tell it, like, when my team investigates, we investigate this way. This is how you should investigate. Or I can add a link here to a run book. And I can jump over here to this root cause, and it runs a bunch of investigations. And then it tells me, like, oh, this is happening due to a database connectivity issue, right? And again, I can go down, I can see the data it relied on to investigate. So this is an example of taking an alert and then giving it an investigation out of the box on that alert, explaining it for the more junior members of your team, and then also for the more senior members, gathering up all that data, doing that investigation, and showing you the results. Okay. And then I want to speak about a few more of the integrations, especially around the open source. So one way that you can use this as well, with the open source, is you can get these better Prometheus alerts in Slack. So you can get Prometheus alerts in Slack with that AI analysis inside those Prometheus alerts. And then the other things that you could do is you could hook this up to various integrations like AppsGenie or PagerDuty, and then right inside Opsgenie or PagerDuty, you could get here this AI analysis, so that when your team is going responding to that through AM in Opsgenie or PagerDuty, then you have that result in the first 30 seconds of starting to investigate. So that's a little bit kind of on the different workflows and like the different places, how you can hook this up to the stuff that your team is already using. And then the last piece of this that I think I want to show before we go over to questions is just on, okay, we spoke a little bit here about safety, right? And giving the AI agent access to limited data. So I just want to show you kind of how you give it access to data sources. So to give it access to Kubernetes, for example, all that we're doing here is we're giving it command lines in Bash. And we're saying it's allowed to run these command lines, and they're templated. So for example, you can run kubectl get, and you can, the LLM, the AI is allowed to pass in like the kinds that would be part of their deployment. Or we could say, oh, you're allowed to fetch logs. To fetch logs, give me a name or a namespace. Those get templated in. And then we'll go off and we'll fetch the logs for that. So we're essentially saying, here are some commands that are pre-approved that you're allowed to go off and run. And the AI is just going and figuring out exactly how to fill in these templates and how to run those commands, but it can't go off and run something that we didn't give it permission to run. Okay, so I think that's the main thing. And then I guess as alongside that, like if you want, imagine that you now want to go off and you want to give it access, for example, to go and like tell you what's the most relevant Grafana dashboard, right? Then you could just put in here as one of those commands, like a curl command to Grafana's API, and then it would be able to go off and now look at the Grafana dashboards and find the most relevant dashboard for you. So getting it access to new data sources becomes really easy. You just have to give it a command that you can go and use to fetch that data.
Very cool. Very cool. So, and none of that sensitive data is stored by the tool itself, right? So you control what you give access to, and you can revoke access whenever.
You completely control what you give access to, and you can use your own large language model hosting your own cloud account. So you have complete control over the data.
This is very, very neat. Very neat. I'm going to take a look through the chat, but while I'm doing this, can you talk a little bit about the open source portion, the types of, I see that you already have contributors. Like I just like to know, like for folks who are watching and maybe this is their jam and they want to get started, they want to help improve the CLI, or they have ideas, like how can folks contribute? And then we'll take a look at questions if that's okay.
So a really good place to start contributing is around the integrations. So for example, the OpenSearch or Elasticsearch integration is probably going to be contributed by one of the large enterprises that's been adopting this.
Okay.
Then we like a lot of the different integrations, like you saw, the integration is just a YAML file with a few commands in it. So that's a really good place to get started. So like imagine you have Splunk and you want to be able to hook this up to data in Splunk. That's really easy to do, and then to contribute that data source back to the community. And we have a Slack community, so anyone can jump on and ask us, and we'll be happy to give you guidance and to assist with that. But that's a really good entry point. And it's a really good entry point because one, is an easy type of contribution, but two, it's a really high value contribution as well. And it's a contribution that will make this better for you using it inside your own company.
Very cool. Very cool. Okay. So if you are working at a company now and you're using a different observability tool and you think this will be awesome to integrate and throw some resources into creating it and then open sourcing it so more people can use it, that's very, very, very awesome. Somebody asked earlier, and I can't find the questions anymore, about GitHub models. You need a GitHub models. Can you integrate with, or can you use GitHub models in this?
So we use under the hood a library called LightLLM, which might be a great one to have on the show if you haven't. I don't know if you've had them. But
no, I haven't. No.
So wonderful open source project, and we love them. I'm not affiliated with them, but we do use their library. And what they do is they abstract away all the different large language models into a library or a proxy. So what we can do by using LightLLM is we can let people bring like their own AWS Bedrock model or Llama 3 whatever model that they're hosting locally. Or someone recently started using a Watson X model, which I didn't even know was a thing from IBM. Or we have someone using now the Oracle models with, I think it's OCI generative AI. We have now someone, this actually isn't in like LLM yet, but I hope it will be soon, using the SAP AI core models, right? So like in the enterprise, surprisingly, you tend to see a lot of these variations with different API gateways that people have to use to access models. And a lot of the common ones are supported in Light LLM. It has 100 plus models. So anything that Light LLM supports, you can potentially use with Robusta, right? There are some technicalities around which models we support and don't. We require certain capabilities. So if you brought like a really, really weak model, that very small, weak model, we probably won't be able to use that. There's some technicalities on what we can and can't use to give you good output, because we like to give you an answer that's reasonable. But for the most part, you can use anything that Light LLM supports. So I don't know if Light LLM supports GitHub models, but if it doesn't, it definitely should. Light LLM is a fantastic library, and it's allowed us to support 100 plus different AI models that I know our customers use a lot of them, at least. And our open source users, our community uses a lot of them. So I would check in the Light LLM documentation about that.
And it's Light LLM. This sounds like homework for me.
LITE LLM.
Okay.
And that's a great library that we're very happy with.
Awesome. That sounds like homework for me to go find them and see, A, if we're supported, and B, can they come and share? This is really great.
They should come on the show. They should come on the show.
Of course.
It's a library that I wish everyone knew more about.
Yeah.
Because everyone knew more about that, then like all the companies that are doing their own LLMs will also go off and contribute implementations back to Light LLM. And then it's better for everyone, for the whole ecosystem. It's better for the vendors because more people can use their models. It's better for the end user because they can choose which model. It's better for the people who create software that uses LLMs, because now we only have to support one implementation and not hundreds.
That is the beauty of open source. You need to put all of that in t-shirts and sell them to support the project. I want to ask you about, and I took a look at the Robusta website, and there are some really interesting case studies there, which you give such an amazing demo today as to why it matters. You kind of took us through the journey, and then we arrived at the solution. The case studies go a little bit more in depth, but I wanted to ask you, just while we have you here, if there is any stories that you can share from changes that you've seen, whether it be in live production scenarios or even open source communities that are starting to use this, from the way that we were working before to this now. And I don't know if there's a specific case study I know there was one about time to remediation, but just particularly, is there any stories stick out that you could share with us?
I do. I want to speak about one in particular, but I can't, unfortunately, reference the company by name.
Chatham House rules. We just talk about the experience, but leave the names out. Let's do it.
Wouldn't Chatham House rules be if I mentioned them, but we all agree not to mention it?
No. You leave the names out, I think. Well, in any case, we're not going to name them. Okay,
deal. Anyway, but there's one where there's this fantastic platform engineering team. And they started with dozens of different application teams, so hundreds of developers running on Kubernetes on the Kubernetes platform that this platform team maintains. But over time, that grew to like dozens to hundreds of engineering teams, and that's thousands of engineers, right? And not in the enterprise, like an unfortunate truth is that there are a lot of great enterprise application developers who have been writing Java apps, right, writing business logic in different languages for 20, 30 years, or their teams have been doing that. But they don't know a lot about the cloud or Kubernetes. And many of the world's enterprises, and not only, but this problem is like especially obvious in the enterprise, many of the world's enterprises have undergone these digital transformations where they've moved to the cloud. And like it or not, like every enterprise developer who used to just focus on applications now has to know a bit about the cloud. So for this organization, for this platform engineering team, that became a big challenge, because their platform engineering team, which had previously been building a platform and like maintaining all the core aspects of that platform, making it really reliable, making it really stable, and delivering like these really good, highly efficient, reliable cloud services, provisioning stuff, doing it in a cost-effective way. They were doing this fantastic engineering work. They kind of became Q&A for developers and kind of developer support, right? And they spent a lot of resources answering questions from developers who would come and say, like, my pod isn't working. Why isn't it working? My pod is crashing. Where can I find the logs? And by adapting Robusta and Homes GPT, they were able to completely offload most of that work again and get developers to self-service, get developers to just open up a chat window, ask those questions, or to look at the different things in Robusta and to look at the AI analysis, and not just the AI features, also just to look at, like, we talk a lot about AI, but like any real solution, even GitHub Copilot, if we're being honest, is not just AI. There's a lot of other real engineering work going on in there, right? And indexing files, doing all these other things. But they were able to go and they were able to get the developers in that organization to really do a lot more on their own, dramatically reducing the load on the platform team. And then one, you're saving all the developers all this time. Two, when there's a problem, the developers are just so more efficient. They don't need to open the ticket anymore and then wait for someone from the platform team to answer, so they can just continue in their work. And then for the platform team, well, they can go back to like really doing more of the engineering work and building these reliable platforms, as opposed to having a big support burden. And that's a story we heard with a lot of our customers and a lot of our, especially in the enterprise, where there are often teams, and smaller teams, and there's just like one person who is on like support rotation each week to answer questions from developers. And I think that's a little bit of an anti-pattern when that goes too far. Because on the one hand, like a big part of platform engineering is supporting your customers, supporting the developers and understanding their needs and their requirements. But done well, you should be understanding their requirements and then giving them a solution, not understanding their requirements and then being the solution.
That is fascinating. I'm sure that team is very happy about not having to do a support rotation. And
we're very happy too working with them. Like from
awesome.
companies like that, when you work with some of the biggest enterprises in the world, then they also give you really high quality feedback on what you need to develop, what features are missing, and having that type of prioritization coming from enterprises really deploying stuff that you build at massive, massive scale to thousands of people is just hugely impactful. And seeing also some of the companies that are going and adopting the open source, like we see sometimes companies going and adopting the open source and like implementing all sorts of parts and things that we've implemented in the SaaS platform. They just want to implement that on their own and integrate that with their enterprise, like with their existing enterprise solutions. We're happy for that too. Like, but seeing all that happen, seeing that level of mass adoption is just really exciting.
That's awesome. And what a great encouragement for other companies when they're seeing that level, at that level, that if it works for Gray Enterprise, it will work for your project. So you can go ahead and adopt
their names publicly.
Exactly.
Through some of the PRs on GitHub and like look at which companies are contributing, but we need to get more of them to come out there and say so themselves. But
that's fantastic.
We'll
this is like exciting stuff for observability. Like I love it. You talked a little bit about the feature feedback loop, and so like how do you see Homes GPT like evolving? Like what's next? Can you share a bit about your roadmap?
Everyone wants remediations.
I was gonna ask what's next, right? Like now I know what's wrong. Can I fix the thing?
So everyone wants remediations.
Remediations
are a little bit trickier because we've done a lot of kind of customer discussions and community discussions around this. What most people want from remediations is human in the loop. So they want an AI to say, here's a remediation, here's what I'm going to do to remediate this, or here's the command I will run, or the change I will make. And they want a human in the loop who pushes confirm.
Yeah.
So that requires doing things slightly differently under the hood, but we have some ideas on how we're going to do that. And then the other part that I'll give you another open source project, that we also have used in which is PromptFoo.
Okay.
And PromptFoo is an evaluation framework. We're actually now looking to making our evals a little bit more sophisticated. So we're looking at a few different options. But prompt foo, and I'll speak about evals in general. Like when you're building an AI feature like this, how do you know it's any good? Or you're going to make a change, right? I told my team, okay, we're going to do remediations. They go off and they do a wonderful remediation capability. Well, LLMs are a little bit harder. Like in traditional software, you have tests and unit tests, right? And you test them, and like then you can say this feature works as expected or it doesn't work as expected. That's harder with large language models and with AI because it's non-deterministic. So
Right.
how do you go off and like verify that the solution you're shipping to people, to the community, and to customers, and that people are relying on in production is actually any good? So the way all the major players do it, like OpenAI themselves, is with what's called evaluations. So essentially, you create a set of representative questions, and you kind of have a benchmark. We're saying like, is it performing well on these or not? And then when you roll out new versions, one, you can check it's not getting worse, so there's regression testing. And then two, you can say like, okay, on the questions that were previously considered hard, where the AI like can only answer 50% of the time, can it now answer 70% of the time? And then you have an objective benchmark of measuring improvements in the model. So that's what's called evals. So this is another major kind of part of how people are building AI software and how we build that and how we do the engineering work. We probably put equal amounts of effort into evaluating the model and evaluating improvements as we do actually building it.
That's pretty awesome. Thank you for sharing that. I do have a question that I want to get to before we run out of time, Nathan, about OpenTelemetry outputs, streaming that instead of Prometheus metrics. And this is from Ravi. And thank you, Ravi, for the question.
Yeah, fantastic question. So the answer one is yes, but I'm gonna leave it as an exercise for as a homework exercise. But I'll give you some hints. So what I would say on that is like, imagine now that I want the AI to be able to go off and query query data in OpenTelemetry, right? Like to bring some of that into the investigation. So imagine for a second, like I'm a human, right? So imagine I'm a human. Like, what would I run in the terminal or do if I wanted to fetch OpenTelemetry data, right? I would probably run wget, and then it depends on where that data is stored, right? But there are some options. And then I would put in some URL, right? And then I would put in like some HTTP endpoint, right? And like params equals, I don't know, like maybe this is the name of the tag that I'm querying data for, or type, whatever. I would put in some query. Again, I don't know the details on exactly what the OpenTelemetry endpoint looks like, so I'm speaking rubbish to some degree here, but I'm trying to get across the concept. And what I would do then is I would like go off and query some of that, and that's how I would do it from the command line. Maybe I can even like let's just try like I would.
You want to share your screen, Nathan, so we can see?
Oh, I'm not sharing my screen. Sorry.
Yeah, no, you were doing an amazing job. Listen, I was visualizing the.
Sorry. I feel very dumb. Okay.
It's all right.
So let's say, how would I query OpenTelemetry data from the CLI with curl? So let's figure out how I would go off and query that.
Okay.
Yeah, so we'll assume that the backend here is, yeah, okay. So OpenTelemetry is just the format for shipping the metrics. We'll assume the backend here is like Jaeger, and I would fetch traces by a service, right? So, actually, I could have a Prometheus backend for OpenTelemetry. I do have a Prometheus in my cluster. I probably don't have enough time left on the stream to actually show it. So let's just say conceptually that would run a command like this, right? So I would run a command like this. So let's just add, I'm going to give Holmes the capability to run a command like that now. So I would do something here like fetch Jaeger traces. In this case, I'll fetch like Jaeger traces that were sent me with OpenTelemetry. And we'll just, we'll leave out the description. I think that's fine. And we'll say, here's the command that you would use to do that. And now I would just parameterize this. So I would say like, this is Jaeger host. And then I would put in here like your service name. And then I'll put in here, like the description will be. And now if I go over to the AI, right, I could say something like, if I go over to Homes, I could say like, fetch Jaeger traces for service EST from my, okay, so I'm going to do something. This won't actually work because I don't even have Jaeger set up, but notice that demand, I need to have the Jaeger host and I need to have the service name. So I'm giving it the service name, and I suspect the first thing that it's going to do is it's going to look at my cluster and it's going to actually try and find Jaeger, because if it can find Jaeger, it can determine the Jaeger host.
Right.
And it's not going to be able to do that. Okay, I don't have detailed to Jaeger host details. So that won't work. I'll try to find Jaeger in the cluster. And again, this won't work because it won't succeed in finding it, but because I don't actually have Jaeger here. But this is kind of how you would hook this up. And then if I really did have Jaeger, then it would be able to go off and like query the data. Okay, look for Jaeger, and it said that you don't have Jaeger. So that's what we expect here. This is failing, but failing in a way that it's actually reporting back to me what the problem is.
Right. No, that's awesome. So the answer is yes, Ravi, you can. Just gotta look underneath the OpenTelemetry, see what it is that you need to plug in, and then that's so cool. That's so cool. Nathan, we're at time. Is there anything else that you want to leave us with? And thank you so much. This was super, super informative. You leaving me with homework of things I want to go check out and teams I want to talk to. Anything else that you'd like to share with our audience? And thank you so much for the solid questions and interactions. Thank you.
I'll end with one thought. Today I'm 32 and running a company that I'm lucky enough to run a company that does a lot with open source and say